Hey, welcome to section 1.5, absolute value equations. First, we'll start by defining absolute value. Absolute value is the distance away from zero. Okay, so if you're doing the absolute value of a number, it would be its distance from zero on the number line. If we're doing the absolute value of x, then it's going to be the distance away from some other quantity on the number line, depending on what x comes out to be. So examples of absolute value graphs. Absolute values graphs can have, there's three different scenarios that you can have. Your absolute value functions always take the form of a V-shape. And if you've got a V-shape that just touches the x-axis in one spot or one point, then this is an example of an equation that has one solution. If you've got one like this where it touches the x-axis in two places, then this absolute value equation has two answers. And it's also possible that you could have an absolute value equation that never touches the x-axis, so that there's no answers. Solving absolute value equations by hand is almost the exact same as solving regular equations, with one major difference. In most cases, you'll have two solutions. For example, if I've got the absolute value of x equal 5, well, that's asking me what numbers are 5 spaces away from 0 on the number line. So if I put in 5 for x, I would have the absolute value of 5 equals 5. That's a true statement. Also, if I had negative 5, absolute value of negative 5 is also 5 spaces from 0, so that's the second answer. So we know that when x equals 5, absolute value of 5 will also equal 5. It is also true that absolute value of negative 5 will equal 5. So for absolute value of x equal 5, you have two solutions, negative 5, positive 5. And this is set notation that is written in here. But both numbers work. So we're going to start by looking at how to isolate absolute value equations. It's very similar to isolating an equation for x. So in my first example, I'm not actually going to, what I'm going to do is my column of regular equations, I'm going to solve for x over here. If I don't see absolute value bars, I'm going to isolate the equation for x. In these examples, I'm just going to practice what would I do if I needed to isolate the whole absolute value quantity by itself on one side, just to show that the steps are very similar. So in the first one, 5x plus 9 equals 144. I know that I can subtract 9 on both sides. Using 5x equals 144 minus 9 would give me 135. And then I can divide both sides by 5. And I get x equals, let's see what that is. $135 divided by 5 gives me 27. In number 1b, I'm going to do the same steps, but I'm going to isolate the absolute value this time. So I'm going to start by subtracting 9 on both sides. I'll have 5 times the absolute value of 3x minus 6 equals 135. And then divide both sides by 5, because this is multiplication. And I have the absolute value of 3x minus 6 equals 27. At this point, I could continue to solve for absolute value, but at this point, I'm just focusing on the steps to get to where I have absolute value by itself on one side of the equation. Part number 2a, I'm going to isolate for x. So I'll add 3 to both sides. X over 7 equals 4. And then multiply both sides by 7. So multiply 7 over 1 times x over 7 and equal 4 times 7. My 7's cancel, so I have x equals 28. I'll do the same steps on 2b. Start by adding 3 to both sides. I'll have the absolute value of 12x minus 8 over 7 equals 1 plus 3 is 4. And now multiply both sides by 7. The 7's on the left cancel. I'm left with absolute value 12x minus 8 equals 28, and then I could continue to solve for x from there. But we haven't talked about how to solve an actual absolute value equation yet. We're just practicing isolating them. Okay, so let's go to the second page. Okay, 3a. All right, so number 3, I have 2/3 x minus 11 equal negative 3. And 3b, I have 2/3 times the quantity, the whole absolute value quantity, minus 11 equal negative 3. So we're going to go through the same steps again. So in the first one, I would start by adding 11 to both sides. So I'll have 2/3 x equals negative 3 plus 11 is 8. And then I could multiply both sides by the reciprocal of 2/3. So multiply both sides by 3/2. So 3/2 times 2/3 just gives me 1. So I've got 1x. And then 8 over 1 times 3/2. 2 goes into 8 4 times. 4 times 3 is 12. So I get x equals 12. In 3b, I'll again start by adding 11 to both sides. I have 2/3 times the absolute value of 2x minus 10 equals 8. Multiply both sides by the reciprocal of 2/3. So 3/2 here and 3/2 here. So that cancels and that cancels. I've got absolute value 2x minus 10 equals, and again that's going to give me 2 into 8 is 4. 4 times 3 is 12. So it gives me the absolute value of 2x minus 10 equals 12. 4a, 4x minus 5 over 3 equals 9. I would start here by multiplying both sides by 3. So I'm going to do 3 times 4x minus 5 over 3 equals, and then multiply the right side by 3. My 3's cancel. So I've got 4x minus 5 equals 27. Then I need to add 5 to both sides. Gives me 4x equals 32. Divide both sides by 4. I get x equals 8. 4b is going to be the same exact steps. Multiply both sides by 3. So when I multiply the left, it's going to cancel. So I'm going to do 3 over 1 times all this and multiply the right side times 3. So these cancel. I'm left with 4 times absolute value 8x minus 16 minus 5 equals 27. Now add 5 to both sides. So 4 times the absolute value of 8x minus 16 equals 32. Divide both sides by this 4 on the outside. So I'm left with the absolute value, 8x minus 16 equals 8. And that's as far as I'm going to go there. So the steps that you follow to isolate your absolute value are the same exact steps that you follow to isolate a regular variable. Now we're ready to talk about how to solve absolute value equations. So the first step when we go to solve absolute value equations is going to be to isolate the absolute value bars, like we've just been doing. Okay, there's a note, never distribute into the absolute value bars. So I always tell students that the absolute value bars are almost like jail bars. You do not get to walk in and out of jail bars. So absolute value bars, you do not get to walk inside and outside of those. Once you've isolated the absolute value, then we're going to split the equation into two like we saw in this earlier example. Okay, but let's start with the first step. So in example 1, if I isolate I've got the absolute value of 2x plus 6 minus 3 equals 13. My first step is to isolate the absolute value bars. So add 3 to both sides. And I've got absolute value 2x plus 6 equals 16. Okay? Then we're going to split the equation into 2 separate cases. And to see how that's going to work, coming back here to when we had absolute value of equal 5, we found that x equal positive 5 and x equal negative 5 were solutions to this equation. So we can follow the same pattern. Whatever is inside the absolute value bars, we're going to set it equal to the constant on the right side. And then whatever is inside the absolute value bars, we're going to set that equal to the opposite of whatever's sitting out here. So in this case, it was x equal 5, x equal negative 5. In my example that I'm doing right now, my 2 cases, and I'm going to label it 2 cases. It's going to be the inside, 2x plus 6 equals the number that's sitting here. Or my second case, 2x plus 6 equals the opposite, so negative 16. Same format. And then we'll solve each for x. So in my first case, I'm going to subtract 6. It's 2x equals 10. Divide by 2 on both sides. I get x equals 5. My second case, subtract 6 on both sides. Gives me 2x equals negative 16 minus 6 is going to give me negative 22. And then divide both sides by 2. X equals negative 11. Okay, but I'm not done. When you're working with absolute value equations, you have to check your solution. So step 3, check your solution by substituting your answer or answers into the original problem. We have to do this step because it is possible for these problems to give us what we call extraneous solutions. It's possible that one of these answers or both of them might not work. So we're going to substitute, we're going to go back and check x equals 5 by putting 5 into the original problem. So absolute value of 2 times 5 plus 6 minus 3 equal 13. And then I'm going to simplify that. That's the absolute value of 10 plus 6, which is 16, minus 3. Absolute value of 16 is 16. And 16 minus 3 is 13. So that does check. So I can put a box around x equal 5. And now I need to do the same for negative 11. So absolute value of 2 times negative 11 plus 6 minus 3 equals 13. Going back to the original problem. Absolute value of negative 22 plus 6 minus 3 equals 13. Negative 22 plus 6 is negative 16. And the absolute value of negative 16 is 16 minus 3 equals 13, so that one also checks. So I can put a box around x equal 5 and x equal negative 11. Example 2, I'm going to a separate sheet of paper. I'm out of space there. So in example 2, we're going to solve 4 times the absolute value of 5x minus 10 plus 23 equal 3. Okay, so to do this, I start by isolating my absolute value bars. So my first step will be to subtract 23 on both sides. I have 4 times the absolute value of 5x minus 10 equals negative 20. And then divide both sides by 4. So absolute value of 5x minus 10 equals negative 5. Okay, now set up your 2 cases. So case 1, the inside of the bars, 5x minus 10 equals the number that I see here, negative 5. Case 2, the inside of the bars, 5x minus 10 equals positive 5. And then go through my steps. So back to case 1, I need to add 10 to both sides. It'll be 5x equals 5. Divide both sides by 5. X equals 1. Case 2, add 10 to both sides. 5x equals 15. And then x equals 3. Okay, and then step 3, I need to check. So going back to the original problem, I had 4 absolute value of 5 times x, so put the 1 in for the x, minus 10 plus 23 equals 3. So 4 times the absolute value, 5 minus 10 is negative 5, plus 23 equals 3. Absolute value of negative 5 is 5, and 4 times 5 is 20. So I have 20 plus 23 equals 3. That definitely does not check. So x equal 1 is no good. I have to throw it out. Case 2, 4 times the absolute value of 5, put the 3 in for the x, minus 10, and then on the outside plus 23 equals 3. Inside the absolute value bars, I have 15 minus 10, so that's 5, plus 23 equals 3. 4 times 5, so absolute value of 5 is 5, and 5 times 4 is 20, plus 23 equals 3. So this one does not check either. 43 is not equal to 3, so x equals 3, I have to throw it out as well. So this is an example of a problem that has no solution. Okay, now if you go back and look at this problem earlier in the process, you might be able to recognize why it turned out to be no solution. Think about what you know about absolute value. Okay, but it is very important to always check your answers. So that was example 2. And now let's look at example 3. Example 3, we have absolute value of x plus 5 equals 3x minus 7. Okay, so this time I already have the absolute value isolated, so that I've already got step 1. I don't have to worry about step 1. Step 2, even though I don't have a constant on the right side, I'm still going to follow the same format that I did before. So for case 1, drop the absolute value bars, set it equal to whatever you see on the right side. So we just drop the bars in case 1. Case 2, drop the bars. And now you're going to do the opposite of the whole right side. So you're going to say negative parentheses 3x minus 7. And now you can solve case 1. I'm going to subtract 3x on both sides. It's negative 2x plus 5 equals negative 7. Subtract 5. Negative 2x equals negative 12. Divide by negative 2. X equals 6. Case 2, I need to distribute my negative. X plus 5 equals negative 3x plus 7. Add 3x to both sides. So it gives me 4x plus 5 equals 7. Subtract 5 on both sides. 4x equals 2. Divide both sides by 4. X equals 2/4, which simplifies to 1/2. Okay, now I have to check. So going back to the original, substitute in 6 for x. The absolute value of 11 equals 18 minus 7. So 11 equals, and 18 minus 7 is 11. So that checks. Put a box around x equals 6. Case 2, go back to the original, substitute in 1/2. 1/2 plus 5 equals 3 times 1/2 minus 7. 1/2 plus 5, that's going to be 5 1/2, or there'll be 11 halves. Absolute value of 11 halves equals 3 halves minus 7, or minus 7 is 14 halves. So absolute value of 11 halves is 11 halves. And 3 halves minus 14 halves is negative 11 halves. And that is not equal, so this one does not check. So the answer is x equals 6 for example 3. All right, and then there's one for you to try. So you pause the video and you solve absolute value 2t minus 3 equals 3t minus 2, and see what that gives you.